So we were discussing about, so in the previous class we discussed about threads. Now in this class we will be discussing about process schedule. Now the thing is that when, let us understand that we all know that a operating system allows multi-programming, or basically whatever operating systems we use, they can basically multi-program. What do you mean by multi-program? There are multiple programs which are running at a once, and basically the thing is that when you are programming one thing, the other also can basically, the other programs are also concurrently running. So supposedly you are running the MS Word Office, the what you can call, you are running the internet browser, you are running some other app. So all these processes are running simultaneously in your computer system, right? Now, what happens in this case, right? In what happens in this case? So supposedly in the in what you know in your MS Word Office, what is happening is that when you are writing something, right? Sometimes it needs to be saved, right? You are trying to save the document. Now, when you are trying to save the document, it takes some amount of time to save it to the hard disk, right? So the time you are writing, we can say that you are writing like on the in the it is a CPU time. You are using some of the CPU time in writing some of the document. And when you are basically trying to save it, it is doing something called input output time. So basically, when you are trying to saving it, you are saving it to some of the secondary memory. In that time, the CPU is not working, right? That is the process, the word processor that you are running is basically waiting for that IO process of saving your data to the hard disk is waiting for that time so that you can again. So after that only you can again write. You are understanding my point, right? Point বুঝতে পারছো?
Yes, sir.
Yes.
So you are writing something on your word, let us think that it is running on the CPU at that time. But when you are trying to save it, that time you are not writing. That time it is being saved to the secondary memory. So at that time, it might be the case that your CPU is remaining idle, right? So at that point, what it does is that the operating system switches your CPU to some other process. So supposedly you are downloading some video, the operating system switches it to the downloading video at that time, right? But it happens so frequently, even the in between your fingertips also, in between your typing of two characters also, that you are not realizing the speed it is happening, right? So this is, but which process? Now there are, maybe there are system processes are also there. There are certain user level processes are also there. So sometimes the processes which are not users, they are waiting for something. So the operating system allocates the CPU to some other process. But the thing is, it is happening so rapidly that you are thinking that you are only interacting with the system. But which process to give to the CPU, that is to be decided. Now let us understand that the operating system is basically nothing. Sorry, the memory, that is the RAM, right? It is why it is called RAM. What is the full form of RAM?
Random access memory.
Yeah, why it is called random access memory? Hey, why it is called random access memory? Somojit, why it is called random access memory?
So because we can directly access the memory locations.
So we can directly randomly access any memory location, right? That is one of the beauties of the random access memory. So it is not a sequential memory, right? Cassette is a sequential memory, but our computer RAM is a random access memory, right? So if it has been a sequential, if our computer memory has been a sequential memory, so all the processes that are going to take place in the CPU, they would have happened in the first in first out list, right? Because the CPU, that is the process which is at first is in the queue, they will only get the queue. So they will only get the CPU. You are understanding?
Yes, sir.
So since the memory is random access memory, we can design some scheduling algorithms to allocate any of the processes as per our wish, or which reaches, or any other processes which increases CPU utilization. Understood? So
So
if you
can you
can
please
just,
repeat the point, last point that you told?
okay. So the thing is that if the memory has been sequential memory, like a cassette memory, so all the processes would have been on the sequential memory. So it would have gone to the memory in a first in first out. The process which is in the sequence first, जैसे तुम लोग लाइन में खड़े हो, द प्रोसेस सिनेमा के लाइन में जो सामने होगा उसी को टिकट काटने को मिलेगा, है ना? That person will only get, that person will only get the CPU, right? But when the process is not, when the memory is our random access memory, we can design algorithms specifically so that system is utilized. So any of the processes in the memory can be selected and allocated to the CPU. You're understanding the point?
Yes, sir. Yes, sir.
So this is the general notion of how the scheduling algorithm takes place. Now there is another general algorithm notation is that there is something called preemptive processes and non-preemptive processes. Now what is a preemptive process? Let us understand about the non-preemptive process. So if a process is in the CPU, if I somehow create an interrupt to remove the process, I cannot simply remove it from the CPU, right? That is called a non-preemptive process. It is sometimes generally necessary for the kernel level processes, because kernel level processes are working on the basically operating system kernel, and it might be changing some operating system data structure. So if you are trying to interrupt that process, so it might happen that for that, if it is a preemptive process, means we can forcibly remove that process, the operating system may function abnormally, right? So non-preemptive processes are those processes which you cannot remove forcibly from the CPU. But for real-time processes, which are nowadays processes, it is necessary that some of the interrupts that arise, it may be external or may be internal, they must be serviced immediately. For that, the process which might be running in the CPU, it has to be removed from the CPU, right? Understood this one?
Yes, sir.
That is the preemptive and the non-preemptive process. Another thing that very important thing is, what is the actual, means how does the process look in the CPU? Sorry, how does the process look in the memory? There are multiple processes, right? How does a process actually look in the CPU, or sorry, in the memory? Any idea? Okay. The process is represented by the process control block. So each and every information and all the metadata and all the required information regarding a
স্যার
process. Yeah.
স্যার আপনি কি পিপিটির পেজটা শেয়ার করছেন?
এখন করিনি,
কারণ
দাঁড়াও
তে-
করবো, এখনো
ও
শুরু
আচ্ছা
হয়নি।
আচ্ছা
So now when we are talking about basically how the processes are represented in the memory, it is actually represented using the process control block, which you learned in the previous classes. Okay, now let us look into the PPT. Okay, now this is what is process scheduling. A process is executing until it must wait typically for the completion of some IO request, right? So the example that I told you about the saving of a document in the hard disk, right? In a simple computer system, the CPU then just sits idle, right? That happens, the CPU is not doing anything. So with multi-programming, when one process has to wait, the operating system takes the CPU away from the process and gives the CPU to another process. So although this is sounding simple, this is not a very simple process. So what is, if the CPU is idle, the operating system allocates it to another process. Understood this one? Now, what is a process? A CPU, a process contains, means sometimes it is working on the CPU, sometimes it is waiting for the IO. So any process is basically a sequential what you can call sequential flow of CPU bursts and IO bursts. So load and store, load, add, store, read from file are called the CPU burst. But it is waiting for IO to happen, that is from reading from file, that is called IO burst. Again, it is storing some, it is running this running this instruction, that is store, increment, index, write to file. So these are CPU bursts. But when it is trying to write to the file or to the hard disk or your secondary memory, it is waiting for an IO, that is called the IO burst. So at this time, this IO burst, the CPU is basically idle, right? So again, when the CPU burst is working, that is load, store, and read from file. So when it is starting to read from file, again it is when it is waiting for an IO to happen. So at that time, the CPU is running idle. At that time, what the operating system does, it allocates the CPU to another process. Understood this one? Bujle?
Yes, sir.
Okay.
Yes, sir.
Now, what is the CPU schedule? The operating system must select one of the processes in the ready queue to be executed, right? So any of the processes. As I told you, it is not a first in, first out. So any can be selected. The selection process is carried out by the short-term scheduler as told in your previous class. What is a short-term scheduler? It selects a process from the ready queue to the CPU. That is the purpose of the short-term scheduler. The scheduler selects the process from the processes in memory that are ready to execute and allocate CPU to that process. So what it does, scheduler selects a process from the processes in memory, and they are ready to execute, and the basically it allocates the CPU to that process. Means if the CPU is idle, it allocates one. It selects a process as per the scheduling algorithm, and it puts it to the CPU to use it. Understood this one? Bujle? Hello.
Yes, sir.
Yes, sir.
So let us say CPU. This is our CPU. This is an our IO, and so let us say so P3. It takes P3 in. So let us say the process P1 is taken in first. So P1 goes in here. So P1 is working in here, right? Now the P1 has to wait for some process. So P1, wait for some IO. So P1 goes to the IO to read some file. At that moment, what it does, the CPU is idle. So at that time, what it does, the operating system, it only selects, let us say, P3 and allocates it to the CPU, right? And when it is working, let us say P1 has completed the job. So P1 is taken out and P1 is again put it in the ready queue. Understood this one? Bujle?
Yes, sir.
Okay, thank you. So preemptive scheduling. So this is very important. So there are 4 instances of CPU scheduling. When the CPU scheduling algorithm works, or that is selection of a process. The first one is when a process switches from the running state to the waiting state. যখনই running state to the waiting state, that is a non-preemptive process. মানে এটা হবেই, এটাকে আটকানো যাবে না, ঠিক আছে? When a process switching from a running state to the ready state, ঠিক আছে? That an interrupt has happened and basically process is in the running state and ওটাকে একটা interrupt আমি ওটাকে সরিয়ে দিলাম processটাকে, it goes to the ready state. When a process switches from the waiting state to the ready state, মানে এবার এটা আবার preemptive হতে পারে, ঠিক আছে? মানে it is in the waiting state, the way IO is complete, now it is again put in the ready state. And when a process terminates, which is a non-preemptive process. So there are 2 non-preemptive processes. When it is in the running to the waiting state, that is, it is waiting for an IO requirement. And when it is a process terminates, that is a non-preemptive process. In here you cannot preempt a process. But these things can be preemptive. That is when a process switches from a running state to the ready state. That an interrupt takes the process out from the CPU and puts it in the ready state. And when a process switches from the waiting state to the ready state, that is also an interrupt. That can also be, that is the IO requirement is happened, complete, and it is again put into the ready state. So where the CPU works basically, so whenever it is in the ready state, so basically the CPU scheduler starts with. So the dispatcher is the module that gives control to the CPU to the. So dispatcher is the module that gives control of the CPU to the process selected by the short-term scheduler. So now, what is the dispatcher works? So some context switch must occur, right? You must do a state save of a process. A process states must be saved. Whatever it was doing, whatever it was program counter value was, whatever its registers value was, they must be stored in the PCB, loaded. They must be stored somewhere. Okay, and that can be that has to be state has to be saved. That process is removed now from the CPU. Another process which has all these values, that is now put in the control of the CPU, and it starts from where it has left off. So that is what we can call as the process restore. So basically, it restores all the value where the earlier process has left the job, and it gives the control of the CPU to the process, and which process? This process which is selected by the short-term scheduler. And this process is called the switching context. So we are switching context from one process to another process. And this job is done by the dispatcher. ঠিক আছে? So I told you that process context switching is not very easy. So we have a separate operating system module called dispatcher. Okay, what are the scheduling criteria? ঠিক আছে? So basically, why do you do scheduling basically? Okay, and how do you basically judge the parameter or performance of a scheduling algorithm? That is one thing is CPU utilization. That is, as the CPU should be kept as busy as possible. That is one of the criteria to basically to check the performance of any scheduling algorithm. That is, if it is keeping the CPU as busy as possible or not. Another is the throughput. What is the throughput? That the number of processes that are completed per unit time. So if the scheduling criteria is better, that means it is the number of processes that are completed per unit time will be better than other scheduling algorithms. Turnaround time. So the moment of time the process is put into the ready queue, and the time of its completion is called the turnaround time. The whole time the process remains within the CPU is called the turnaround time, from the ready queue to its completion. Okay, waiting time. The sum of periods spent waiting in the ready queue. So what is the time? That is the process waits in the ready queue is called the waiting time. So these are different performance criteria to judge a scheduling algorithm. And what is the response time? Time from submission from the request until the first response is produced. So you have submitted a process for its execution, and it is in the ready queue, and the first response it makes, that is called the response time. So these are the different judging criteria of scheduling algorithms. Understood? Hey, you all understood?
Yes, sir.
Yes, sir.
Yes, sir.
এই তোমরা সবাই সবকিছু বুঝে নিয়েছো? কোনো কোশ্চেন থেকে জিজ্ঞেস করো।
हाँ सर समझ गए।
1 second. Okay, hello. So now you understood these points. Okay. So I have already given you the PowerPoint presentation. Start reading them, right? So tomorrow I'll be giving you some assignments, and maybe a class test might happen in the first week or first day of the Monday. Okay. ঠিক আছে? বুঝতে পেরেছো? Hello.
Okay, sir.
हाँ सर।
ঠিক আছে. Okay, fine. So you can give your attendance in here.
सर कैसा है सर?
चल रहा है भाई जिंदगी. Okay, fine. Everyone is given their attendance.
तबीयत ठीक है ना सर?
हाँ भैया सब ठीक है, अभी तक देखो क्या होता है, अभी तो थर्ड वेव आने वाला है। अभी तो आराम से आप लोग स्वस्थ रहिए और क्या, पढ़ाई वढ़ाई कीजिए। ठीक है,
हाँ
मैं
सर,
बाद में बात करता हूँ, ठीक है ना, विल टॉक अगेन
ठीक है
लेटर।
सर। हाँ सर।